Machine learning is a really vast field with complex sock-filled taxonomy. It's very difficult to really create a good taxonomy for the field of machine learning. But generally, machine learning algorithms fall into four broad categories. You may have heard of this: supervised learning, unsupervised learning, self-supervised learning, and reinforcement learning. In the case of supervised learning, what we do is we have a data where we have enough models for the model to learn from the data. So say you create 200 pictures of you or someone else, and you also have the corresponding labels: happy, let's say neutral, let's say sad. So you have these all the input X, and you have the corresponding labels Y. And if you're feeding a model both your input X and Y to learn from the model, that's supervised learning. Unsupervised learning is, say you have these 200 pictures, but you don't have the labels for them. So the labels are absent. In that case, you can do clustering to group pictures that look similar and so on. So that would be unsupervised learning. Self-supervised learning is that when you have these pictures, it tries to come up with labels on its own. The algorithm tries to come up with the labels on its own, and then does classification or learns to make predictions. Now, reinforcement learning is a totally different topic, which is more like usually used for game playing. Whenever you have a way in which you can score or rank, if you have a way in which you can obtain a score, then reinforcement learning comes into play, such that the machine you program, you design, your program continuously tries to update itself in order to improve the score. This is particularly helpful when designing automatic game playing agents and things like that. So let's dive a little bit into detail into all these kinds of machine learning techniques. The first one, let's look at the supervised learning. In supervised learning, it consists of learning to map the input data to known targets, also known as annotations. So in the example earlier, say you have a picture and then a picture of somebody, and then the label would be happy, sad, or neutral, etc. So the problem here is to map this picture to the output. So this mapping is something that the network has to learn, or this function is what the network has to learn. And these annotations given a set of examples, often annotated by humans. Usually we create these annotated data sets. Some quite uncommon examples of supervised learning are sequence generation. So here, given a picture, the problem is to predict a caption describing it. So if we have a picture like this as input, then what we would like to predict is a caption that looks like this. For example, the caption here is a female tennis player in action on the court. So another example would be, here we have another picture and we would like to generate captions like these. Another uncommon example of supervised learning is syntax tree prediction that looks like this. So given a language, for example, a sentence, there was no attempt at robbery, what we would like to do is create a syntax tree. That's also another example of supervised learning. Another example of supervised learning is object detection. So given a picture, draw a bounding box around certain objects. For example, if this was our input picture, then the supervised learning algorithm will have to detect where's the laptop, basically draw a bounding box around the various object it detects. Another uncommon example is image segmentation. So given pictures like these, the algorithm has to, so be given pictures like these, the algorithm has to come up with outputs that look like this, but basically highlighting the region where the object of interest lies in the picture. So basically the problem is, so given a picture, we want to draw a pixel level mask on the specific object in the picture. The next branch of machine learning is unsupervised learning. And in the case of unsupervised learning, what we want to do is find interesting transformations of the input data. without the help of any targets. So we don't know the actual labels. Usually for the purpose of either data visualization, that is, if we have a lot of pictures, then we can simply cluster them to maybe find out what proportion of people are happy and what proportions of people are sad, etc. For the purpose of data compression, data denoising, that is cleaning data, removing noise, or to better understand the correlations present in the data at hand. So we could have many reasons why we want to do unsupervised learning. Now, unsupervised learning is the bread and butter of data analytics. So if you have a database and whether you do machine learning or anything else, unsupervised learning is something that you do at first. You look at the data, number of rows, number of columns, you check for errors and things like that. It's often a necessary step in better understanding a data set before attempting to solve a supervised learning problem. So basic neural network training is slower when two features are highly correlated. For example, I mean, if we are using fundamental neural networks or like classical neural networks, then if two features are very highly correlated, if two columns are highly correlated, then it's better to get rid of one of them. Now, this is no longer true for deep learning, but for classical machine learning techniques, this becomes it's helpful to remove a highly correlated feature. Another good example is dimensionality reduction and clustering, where these are also very well-known categories of unsupervised learning. For example, principal component analysis and finding clusters in given data sets and so on. The next branch of machine learning is self-supervised learning, and self-supervised learning is another interesting area. And in self-supervised learning, we do supervised learning, but without human annotated labels. So it is in a way supervised learning, but without any humans in the loop. There are still labels involved. That is, we still have the outputs, for example, happy, sad, and etc. But they are generated from the input data, typically using some heuristic algorithm. One good examples of self-supervised learning are something known as autoencoders. Now, in this course, we're not going to talk in detail about them, but they are a really good example of that. In autoencoders, what happens is, say you have an input image that looks like this. So this is your input image. Your convolutional neural network or some network, your neurons in the middle, somehow transform this into a latent representation where this is a 2D or 3D matrix, maybe a 2D or 3D matrix, where visualizing this does not give us a 4 or anything that looks like 4, but it's a latent representation, a machine learning's own way of representing 4. But then we can design another set of neural network to decode this information to once again retrieve this picture, the 4 back. So this is in a way self-supervised learning because the model in a way comes up with its own representation for the input 4, and it can even recognize that whenever it finds such a latent representation. Other examples of self-supervised learning are, say we want to predict the next frame in a video given the past frames. This is one example. Another example is to try to predict the next word in a text given previous words. So these are texts that can be very well done with things like autoencoders, and they are all examples of self-supervised learning problems. Now, sadly, the distinction between supervised, self-supervised, and unsupervised learning can be blurry sometimes. And it's okay because depending upon how we look at the problem, it can be either classified as self-supervised or maybe unsupervised or even supervised problem. These categories are more of a continuum without solid borders. Sometimes self-supervised learning can be represented or reinterpreted as either a supervised or an unsupervised learning, depending upon whether you paid attention to the learning mechanism or the context of its application. So if it's being applied to a problem where the labels are easy and human generated or humans are in the loop of generating, then even the self-supervised learning may be considered as a supervised learning. The next area or the branch of machine learning is reinforcement learning. Now, this is a relatively new area and it's still under investigation and active research area within the topic of machine learning. It's mostly a research area and hasn't had a significant practical success beyond games. And in reinforcement learning, an agent receives information about his environment and learn to choose actions that will maximize some reward. So say you have a Mario that's playing a game, then we can train or create a Mario with neurons in it such that every time it gets a better score, it keeps moving in that direction. One good example is, say, for example, a neural network that looks at a video game screen and outputs the game actions in order to maximize its score. So this score is always that can help the model understand whether it's going in the right direction or the wrong direction. And this can be trained via reinforcement learning.